Hey guys, so today we're going to go over question number 2A, B, C, and D. Let's get started. So the data table below shows the mass of a sample of radioactive carbon 14 remaining after each half-life. So these are the half-lives that the carbon 14 is going through, and this is how much carbon 14 we started with before the half-lives and how much we have left with each half-life. 2A is asking, on the grid below, construct a line graph by plotting the data from the mass of carbon 14 in the sample for each half-life in the data table. Connect the plots with the line. So I know carbon 14 is a radioactive isotope. So I know since it's a radioactive isotope, with each half life, it should be decreasing. And whatever product that is stable that it's creating, I know carbon 14 creates nitrogen 14, that product should be increasing. So when I plot this graph, it should look something like this. Go ahead and pause this video and complete your graph if you haven't already. Okay, so 2B is asking, identify the stable disintegration product of the radioactive isotope carbon 14. So to find the stable disintegration product, all I need to do is go on my reference table page 1 chart, and I see that the disintegration for carbon 14 is actually 14, nitrogen 14. So your options for your answer are 14N, nitrogen 14, N14. Please do not just write nitrogen because nitrogen is a stable element. It's not an isotope. Nitrogen alone, because nitrogen has more than one isotope and the stable disintegration product is needed. There's different nitrogens with different amounts of protons and neutrons, and therefore you can't just say nitrogen. Nitrogen 14 is different. So finally, C. Determine the number of grams of carbon 14 remaining in this sample at 17,100 years. So to figure this out, I need to figure out how many half-lives carbon 14 went through in 17,100 years. So I know one half-life for carbon 14 has 5,700 years. So what I did is just divide. So 17,100 years divided by 5,000 years, 5,700 years gives me 3. So since I divided this many years with my amount of half-lives, now I know, or the amount timing of half-lives, now I know how many half-lives carbon 14 went through, which is 3 half-lives. So I know in 17,100 years, my carbon 14 went through 3 half-lives. Now that I know that, I can figure out how many grams of carbon 14 is left in 3 half-lives. If I go to the chart they gave me, after 3 half-lives, I'm only left with 8 grams of carbon 14. Therefore, the answer is 8 grams. Finally, D. Explain why carbon 14 could not be used to find the age of the Coliphus fossil. So, like I said before, for a question like this, why can't we use carbon 14 to date the age of a certain fossil that is older? Or why is it that we only use carbon 14 for younger fossils? The answer is always carbon 14 has a very short half life. And you can go back to your notes for this. Carbon 14 has a short half life. Here are some other examples or options for your answers. Carbon 14 has a short half life, or after a million years, there would not be enough carbon 14. Carbon 14 decays quickly. The organic remains are too old to be dated with carbon 14. Too little of the original radioactive sample would remain. So pick any of these answers and that would be fine. So go ahead and try questions 3, 4, 5, and 6.